So, good morning, Rio. Well, I welcome you for this session, which is very important, very important topic. That is acid-based titrations. What do you mean by acid-based titration? Why do we do acid-based titration? This is a very important topic. What I am talking is acid-based titrations. Do you have any idea what is a titration? Why we do it? See,
To find an unknown value, sorry,
unknown.
unknown solution.
Actually, you see that supposing you have an acid, if you have an acid which whose concentration is known to you, that means whose molarity is known to you, whose strength is known to you, but you have a base whose concentration is not known to you. Then what we can do? There is a method which is used titration. In titration, what we do? In titration, what we do in titration? देखो, you have an acid. You have an acid. ठीक है? And you are taking the acid in a there's a conical flask. There's a my conical flask or a beaker You are taking the acid here. ठीक है? Or I say that here is a beaker in which you are taking the acid. ठीक है? This is my acid. And then you will add base from the burette. Here is a diagram of that. You can see that here is our acid. Acid is in this. This is a beaker in which I have taken acid. And from the burette, this is my burette. This is my burette. From the burette, I am adding base. I am adding base. What is our base here? If I am doing the titration of strong acid, I am saying strong acid and strong base. Strong base. What is a strong acid? Which is completely ionized. For example, we are taking here hydrochloric acid, HCl. HCl is a strong acid and NaOH is a strong base. Yes or no?
Yes.
Okay. HCl is a strong acid, NaOH is a strong base. Then when I will do that titration, I will take sodium hydroxide I am taking in the burette, NaOH I am taking in the burette, and HCl, my HCl, which is a strong acid, is present in this beaker. Okay?
Yes, sir.
And in every titration, I am going to explain that there are few points which are very important. One is the equivalence point. Then we will also talk of the end point. And for that, we will have to use some indicators. We are going to find answers to all these questions here. What type of indicators can be used for what type of titrations? So basically, in this case, we are doing a titration of a strong acid with a strong base. And what we are saying, the titration, we have to make a titration curve. What is a titration curve? We will draw a titration curve. What is a titration curve? We will take two axes and we will make a graph of pH versus the volume of alkali. Here is NaOH added. Volume of NaOH added. How much NaOH we will add? What is happening? In this beaker? What I am saying that I have taken a 25 milliliter of hydrochloric acid, 25 centimeter cube of HCl I am taking, which is 0.1. What is the concentration of that? 0.1 mole decimeter cube. Okay? I take 25 milliliter of HCl in this. What is the concentration? 0.1 mole per liter or 0.1 mole per decimeter cube. This is 25 milliliter. What I will do now? In the burette, what I am doing in the burette, I have this is my beaker. This is in the beaker, students. Okay? And from the burette, what I am doing, I am adding NaOH. Supposing I add 1 milliliter of NaOH. In the beginning, I am saying I am adding 1 milliliter of NaOH. What will happen? HCl has got what? When I am saying, you are saying there is HCl. Hydrochloric acid aqueous. You have what ions HCl give? H plus ions. You already know.
Yes.
HCl is a strong acid. It will be ionized to give Cl minus and H ions. Okay? These are the ions. If you have 0.1 mole of this, what will be this? 0.1, because it is completely ionized. This also 0.1. Okay? Correct?
Yes, sir.
But you have 0.1 mole decimeter cube. If I take the concentration to be, if you are saying the concentration of H ions is how much then? The concentration of H ions is 0.1 mole decimeter inverse. And that is the molarity which you have taken. And then how do you calculate the pH? Minus log to the base 10 of H plus H plus. Okay?
Yes, sir.
If you have 0.1 molarity is this molar concentration is 0.1, then what will be the value? Minus log into 10 minus 1. That will come to be 1.
Yes.
pH, at the starting time, what you are saying, the pH of HCl is 1. And what is the NaOH volume? 0. Okay?
Yes.
When I have added 0, the pH is 1. Now you are saying you start adding NaOH in HCl. What will happen? As you start adding NaOH, supposing I add 5 milliliter of NaOH, then what will happen? What will happen to the pH? Tell me, what is the OH minus doing?
The pH
Sodium
will,
hydroxide will give you what? Sodium ions and
OH
hydroxide ions, and it will neutralize OH H plus to give
water.
water. So the concentration of H ion will decrease. Therefore, the pH will increase. If H plus decreases, the pH increases. That you know. So, but how much will it increase? How much it will increase? You can see that if I will add 5 milliliter of NaOH, then we have to see that how many moles of HCl were present and how many moles of HCl are neutralized. How many moles of HCl are neutralized? Then we can be able to find the pH in this case. The starting pH, we are saying the starting pH here is a graph which I have shown, which I will tell you how we have drawn it. The starting pH is how much? Starting pH is how much? 1. Okay? Now you have added 5 milliliter, the pH will slightly increase. The pH will slightly increase. I'm saying how much we can make a calculation of that by this. If I add 10 milliliter, the pH also increases, but if we make all the calculation, we will find the pH comes to around 1.37. If I add 10 milliliter of NaOH, the pH increases by very small amount. Students, you can see 1.37, 1 to 1.37. And if you add 24 milliliter of NaOH, the pH becomes around 2.69. But you can see it is increasing, but the increase is slow. Increase is slow. How can we explain this? Okay, let me say why I will tell you what we are doing. You have noted down this, I can rub this. What we are trying to study, what is all about titration, what is titration. So sodium hydroxide is in the burette. HCl, how much HCl I have taken? 25 milliliter of HCl I have taken, which is 0.1 molar, 0.1 mole decimeter inverse. And you can see that when will be the complete neutralization take place? When the moles of the NaOH and moles of the OH minus and moles of the H ion becomes equal. When the two become equal, there will be exact neutralization. There will be exact neutralization. Let us see how the pH is changing. How the pH is changing. This is the example of a strong base and strong acid titration. I have to draw the titration curve. I have to draw the titration curve. What I am titration curve? I am drawing strong base and strong acid. Strong base and strong acid titration. What is the calculation? We have to do the calculation to find how many moles are used. Okay, what we are saying, what we are saying to you now, what has happened that I started with HCl and it gives me H plus aqueous and Cl minus. It is completely ionized. Now, in the beginning, what you are having 25 centimeter cube. You are having 25 centimeter cube and 25 milliliter of how much? 0.1 mole decimeter cube of HCl. Right? How much I have in the beaker? 25 centimeter cube of HCl, which is 25 milliliter, which is 25 milliliter. 0.1 mole decimeter means 1000 milliliter will contain 0.1 mole. And if I have 25 milliliter or centimeter, this is milliliter is centimeter cube, supposing. Same thing. So 25 centimeter cube I have taken. How many moles will be there? 0.1 into 25 by 1000. Okay? How many moles it will come? You can do the calculation. 40. So this is coming to be 1 by 4 into 100. That means how much? 0.25. 10 by 4 is 2.5. So 10 by 4 is point. How much is this moles? 1 by 4 is how much? 0.25 by 100. So you are starting with how many moles of H plus in this case? How many moles of H plus you have according to this calculation? When you started, how many moles you are having? 0.0025 moles of H plus. Okay? Got
Yes,
it?
sir.
The moles of H plus is 0.0025 in how much solution? 25 centimeters. And when I calculate the pH, how do I calculate the pH? You are saying pH of this is 0.1 mole decimeter cube will be 1. Okay? We calculated that. pH is 1. So we are starting. This is my pH. This is the volume of the NaOH added. But we will be plotting at when pH is 1. What is the volume of NaOH added?
0.
0 volume. Now, as I will start adding OH minus, what will happen? NaOH gives me what? NaOH will give me sodium ions and hydroxide ion.
Science.
So when I will add this, this moles of H plus will be used. How much? As much as this is coming. As much as this is coming. So what we find is that if I add 10 milliliter of NaOH, if I add 10 milliliter of NaOH, that how many moles of OH minus will be produced? What is the molarity of the NaOH, you are saying 0.1 mole decimeter cube. NaOH is 0.1 mole decimeter inverse. That means 1000 milliliter will contain how much? 0.1 mole of OH minus. Then 10 milliliter will contain how much? 0.1 into 10 by 1000. So what is that value coming to be? 0.001. 0.001 of OH minus. So what is the reaction then? You are having H plus OH minus gives you water. Okay? This was in the, how much was this? 25 centimeter cube was how much? 0.0025. Now how much you have added? 0.001. So this will become minus 0.001. The value will decrease by this much amount. H ions. So the H ion concentration is decreasing. H ion concentration is decreasing. How much it decreases? 0.0025, and this, if I subtract, how much it will be? 0.0025, 0.001. How much it comes? 5. So you are left with how much? H plus 0.0015. Yes or no?
Yes, sir.
This is used up, but it is excess. This is a limiting reagent. This is a limiting reagent. You have added only 10 milliliter. So many moles of H plus are left now. But what is the total volume of the solution now? 25 centimeter cube of HCl was present. You have added 10 milliliter of NaOH. What is the total volume of the solution? Total volume of the solution is how much now? 25 plus 10, 35 milliliter. Okay?
Okay, sir.
Now 35 milliliter of solution contains how much? 0.0015 moles of H plus. You have to find the pH, then you have to use the concentration. Find the concentration means in molarity. How many? In 1000 milliliter, how many moles will be there? 0.0015 into 1000 divided by 35. So this will give me the molar, this will give me mole decimeter inverse of H plus. Mole decimeter inverse of H plus. Once I get this, I can find the pH. I can find the pH. And if you will do all this calculation, with your calculator, you will find that when I have added 10 milliliter of NaOH, the pH changes to 1.37. This is my pH. Okay? You know how I am calculating? I am adding NaOH from this burette in the HCl. HCl is a strong acid. And what is happening? The H ions are present here. They are neutralized by OH minus. And the pH will change. But the change in pH is very small. Why? Because pH is minus log of H plus. You can see that minus log of H plus will mean the logarithm is a function which will decrease the change in pH. So 10 milliliter pH is 1.37. Then what I say, okay, I add 25 milliliter of NaOH. And if you do all this calculation, which I have shown you, this you can calculate with the calculator, na? How much value it will come. You can do it by the calculator. Yes. And then you can find the pH by using the formula. Yes or no? Any difficulty here? Tell me. Sir. Okay. Therefore, what we are seeing that we can easily find the value of the pH. And you will find, if you do the calculation, if you add 25 milliliter of NaOH, the pH comes to be 2.69. 2.69. But as soon as you add 25 milliliter of NaOH, just 1 milliliter change, what happens? Dekho, what is this? You are using 25 centimeter cube. This is my milliliter or centimeter cube. They are the same things. You are having 25 centimeter cube, okay, of 0.1 HCl, 0.1 molar HCl. Now, if you add in this 25 centimeter cube of 0.1 molar NaH, what will happen? This means the number of H ions now is equal to number of OH ions. What is here? There is an equal number of equal moles of, you have equal moles of H ions and equal moles of OH ions in this solution. Yes or no?
Yes, sir.
So equal, you have equal moles of equal moles. You have now equal moles of H plus and OH minus. Therefore, what will be the result? H2O. Complete neutralization. There is no H plus now. There is no OH minus. When you have added 25 milliliter, the result will be what? The pH will increase. The pH will increase now. There will be a sharp increase in pH. The pH becomes 7. The pH here becomes 7. That is the pH of the water. You know what is the pH of the neutral water? pH of the neutral water, you know. The pH will become 7. This is the equivalence point. What is this called? Equivalence point of the titration. They will ask you in an exam a question, what is the equivalence point, students? When equal moles of acid and base have been added in the reaction flask, at that point, what happens? This is called equivalence point. Equivalence point. That means equal moles of the base and equal moles of the acid are present. At that point, we are saying complete neutralization takes place. And in the case of strong acid and strong base, the pH becomes 7. The pH becomes 7. Okay? Now you add more base, what will happen? This you have noted down? How I have done the calculation? Because I will be drawing what I want to do. I want to draw the titration curve. What I am saying, pH titration curve we want to draw. Okay? So what we are saying now, that equivalence point. What is equivalence point? That point when the moles of the alkali NaOH and moles of the acid are equal, the moles of H plus and moles of OH minus are equal in the flask where the reaction is taking place. That is the equivalence point. That you are saying there is no OH minus now, no H plus, they are completely neutralized. You have equal moles of the titrant and the substance which is being titrated. So in your book, you will also see they have made a table. They have made a table of the change in pH. How you are measuring the pH? By pH meter. I have a pH meter attached. Yes or no?
Yes.
So I will keep on adding NaOH 1 milliliter, 2 milliliter, 3 milliliter, 4 milliliter. And after adding that, what I will do? I will then find the pH by pH meter, and how much pH will change. We have shown the calculations, because H plus ion, how many H plus ions are present, how many moles of H plus ions are present, and how many moles of NaOH OH ions are being added, they will neutralize each other. At the equivalence point, you have equal moles of H plus and equal moles of OH minus. That is our equivalence.
Yes. Yes, sir.
Okay. So we know that you have equal moles of at the equivalence point. Then after 7, if you add, this is 25 centimeter cube. Now I add 26 centimeter cube. And you will see the pH will go 11.29. Can you tell me why the pH has gone to 11.29 now? H plus ion is finished in the reaction. You had H plus and OH minus. At equivalence point, what happened? At equivalence point, equivalence point is when you have 25 milliliter of 0.1 H plus 25 milliliter of 25 milliliter of OH minus 0.1. So you have equal of this. Both are 0.1, 0.1. Volume 25, 25. So H plus is completely finished by at this point. No more H plus in the flask. Do you have any H plus here now? Tell me, do you have any H plus? Do you have, it is consumed?
Yeah.
Now, if you add more NaOH, what it will give you? It will give you N plus and OH minus. Now the concentration of OH ion is increasing. When OH ion increases, what happens to the pH? pH will increase. 7 is a neutral point. Yes. And after that, what happens? pH will increase because of the presence of OH minus. And OH is a strong base. So if we will do the calculation, you will find the calculation how much OH ions are present. What is the concentration of OH ions? If you find the OH ion concentration, then you can find the POH, and then you can find pH plus POH is 14. So you will find the value is 11.29. And after that, you can keep on adding 30 milliliter or go up to 50 milliliter. The pH will become, once it reaches, it will become 12.5 and then almost constant, 12.5. Why? Because NaOH is NaOH is a strong base, completely ionized. So once the concentration of OH ion is ionized, what is going to be the pH then? Then it will become constant. Then if I have these points, if I draw a curve now, what curve I'm drawing? pH versus volume of NaOH added. Okay? If I draw this curve, what type of curve I'm getting according to these? I can plot these values. You are saying HCl first starting point of HCl pH was how much? Tell me how much was the pH? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, you can. Here I've shown this graph. We have given plots of this. You started from which point? What was the starting pH? Tell me, what is the starting pH when I took HCl?
1.
1. It started from here, 1. Then slowly increased. This is my volume which I'm adding. How much volume you are adding? 5, 10, 15, 20, 25, 30, and you can go up to supposing or 30, so 40 and so on. Okay? What happened? This is the point 25 milliliter. This is the point where you have equal moles of HCl and NaOH.
Yes, sir.
What was happening? First, it was increasing slowly. Slow increase. And at this point, when you have added 25 milliliter, there is a sharp increase. Okay? As you can see. Big increase like this, and pH 7. This is my pH 7. This is at equivalence point. At equivalence point, the pH goes to 7. In case of strong acid and strong base titration. And as you add more As you add more, what happens? 11.29. If you add more of, if you add 26, 25 to 26, then what you start finding? That this is increasing, and at 26 it becomes 11 point. This is my 10. This is my 11.29. So this value is, you can see that this curve like this, and then it becomes like this. So this is the titration curve which you will get for strong base and strong acid. Tell me any doubt here?
No, sir.
Okay. Now here we have shown this exact measurements. Exact measurements we have shown here. What is the importance of it? Very important curve. This is our pH 0, 1, 2, 3, 4, and this is the volume of NaOH added. So in the beginning, you can see there is a small increase in the pH, but at this point, you can see that when 25 milliliter, this is 25 milliliter. What is this point known as? Tell me. Equivalence point. Equivalence point. At the equivalence point, you have equal number of moles of, you have equal number of moles of H plus equal to OH minus aqueous, right?
Yes.
And we can say that the reaction is finished. Reaction is finished because you have used all the moles of H ions which were present in the solution. Now there should be something to indicate the end of the reaction. How will we say that the reaction end point has come? That is known as the end point of the reaction. End point. So we need to know when we are titrating anything, we are titrating a strong base and strong acid here. We want to know when the end point has come. Can you tell me how do you know the end point has come? What do you use? What do you use to know the end point? Indicator?
Yes, sir.
What is an indicator? It will change its color
It will, sir.
at the equivalence point, or there should be a range. There should be a range where it should change its color. So if I add that indicator, what will happen? Up to 24 milliliter, nothing. But as soon as I go to 25 milliliter, then you can see the pH is immediately changing from here. You can see 24 milliliter pH is 2.69. But as soon as I add one more milliliter, the pH is 7. There's a large increase. There's a large increase. You can see that. Here, you can see the pH change is large. 2.69 to 7. And then here you can see this is a region where the pH is changing very sharply, around 7 to 11.29. So we should have an indicator which changes its color in this range, in the range of the equivalence point. And there are indicators which have different colors, in different pH range. pH range I am saying now. Which pH range I will use for the, in the case of a strong acid and strong base, this where there is a large change in pH. You can see large change in pH. So therefore, in order to understand in order to find the end point, the completion of such a titration, we will be using an indicator. And let me see what indicator I'm talking about. Dekho, you will note down the equivalence point is a point at which equivalent number of moles of acid and base have been added. But I'm saying equal numbers of moles of acid and base have been added. That point is known as equivalence point.
Yes, sir.
And in case of a strong acid and strong base, the pH at the equivalence point is 7. pH is how much? 7. base and strong acid.
Will the pH at the equivalence point change if the base is weak?
Yes, 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 yes. Very good question. Very good question. Because we will show you. That's what I want to tell you. That question will be asked in the paper also. For strong acid and strong base, the pH is equal to 7 at equivalence point.
So the pH at the equivalence point depends on the concentration of the acid.
It depends on the acid is weak or base is weak. According to that, it will change. It
Okay.
will change. That is a very good question. What we are saying for strong base and strong acid titration at the equivalence point. At the equivalence point. What is the pH? 7. But will not be true. Will not be true for weak acid, weak base, strong, weak acid, strong base, etc. titration. The answer will not be same, you know. Why, that we will tell you. That was your question. Okay? It will not be 7. It will not be 7. If I have a strong base, and weak acid, then pH will not be 7. Will not be 7. We'll see.
Will the pH decrease?
We'll show you what it happens, because what type of salt will be formed. We'll see that. Because in this reaction, let me tell you what has happened. NaOH plus HCl. Okay? What is the reaction? H2O, okay, plus NaCl aqueous. What is this? This is a salt. NaCl is a salt. Aqueous here, okay? It dissolved in the water. This is a salt. This is a neutral salt. It is a neutral salt. If salt is acidic or basic, according to that, the pH will change. Water is neutral, salt is neutral. So what is the total pH? pH here depends on, you are saying water neutral. Okay?
Yeah.
Salt neutral. Therefore, the pH is 7. But if the salt is not neutral, what will happen? There will be some pH. Less than 7 or more than 7 will depend on what type of acid-base titration we are doing. That was a very good question asked by you, Rio. Very good question. Be careful in the paper, you know, you revise everything. You will revise all the questions which you have done in your notes on acid basis. All the questions are coming from there. Numericals will be asked, which you have done, how to make tables. Any doubt here? Now you got it. You got it. You understood how we are drawing the pH titration curve? I am taking in the burette alkali, I am taking acid in a conical flask or a beaker, and I have a pH meter. What pH meter will do? Record the pH value. And if you starting point, you know, strong acid will have a pH of 1. If you have 0.1 molar means what? 0.1 molar will have pH of 1. Then you keep on adding 1 milliliter, 2 milliliter, 3 milliliter, like this you are adding NaOH, and keep recording the pH values from pH meter. You will have a table, and then you will plot these values, and you will see what type of pH curve you are getting for strong acid and strong base. This is the nature of the graph. You can see. Can you see this?
Yes, sir.
This curve is for strong acid and strong base. And what is the pH for a strong acid and strong base at an equivalence point? 7? 7?
Yes, sir.
This is the pH. You can see in this case, if this is my 7. This is the point, this is the equivalent point, 7 pH. At this point, you have equivalent moles of acid and equivalent moles of base. And the salt is neutral, water is neutral, therefore pH is 7. It will not be true if acid is weak and base is strong, or base is weak and acid is strong, then this value will not be 7. Now I have to choose an indicator. What I have to choose? I have to choose an indicator. You want an indicator to tell me the end point. ठीक है, indicator will tell me what? I need an indicator. Indicator tells me what? So indicator tells me the end point. That end point has reached. Their indicator will change its color. Indicator will change its color. So this is the point. You can see that here there is a maximum change in pH. So I should choose an indicator which should have this range. The indicators, what we are saying, the indicators have a range over which they change the color. Over which they change color. And here I have shown you in this case, the pH change is coming from where? This is, you can see what is this value? This value, how much pH is changing? What is the range of the pH here, students? What you can see, you can see around 3 point something to, it is changing from to 10 here 10.5. So from 3.5 to 10.4, something like that. In this case, the pH changes from supposing 3.6 to 10.5 supposing. So I should have an indicator which changes its color in this range. In this range, you can see that this is 3 point something and this value is 10 point something. Okay? The pH should change color in this range. Got it? And we have 3 possible indicators for strong acid and strong base. Methyl orange changes color in this range. Methyl orange changes its color in this range. Litmus changes color in this range. Phenolphthalein also changes color in this range. So we can use these indicators. There are more: bromothymol, phenol red. They change their color in this pH range. Hence we can use such indicators. So the use of indicator also depends on the range in which there is a change in the pH. Change in the pH. Any doubt here? So we can use phenolphthalein, can be used as a good indicator, because phenolphthalein, what will happen? Phenolphthalein will change its color. What will be the color of phenolphthalein in the acid? Phenolphthalein, if you will add phenolphthalein in acid, you have taken 25 centimeter cube of 0.1 mole decimeter cube of HCl. It will be colorless. But as soon as at equivalence point, what will happen? At equivalence point, what will happen? The pH will shift from how much? 3.6 to 10.5. And in this range, phenolphthalein changes its color from colorless to pink. What you will see in that? What you will see in the flask? Pink color. Okay? The color will change. When the color will change from colorless to pink, that means the reaction is complete. That will be the end point. Got it?
Yes, sir.
Therefore, when we will do the titration, we can do this. And once we know the volume of NaOH which completely neutralize the NaOH, then we can find the strength of this. There is a formula which can be used: N1V1 is equal to N2V2. This is the normality of the HCl, which is known to me. This is the volume of HCl. This is the normality of NaOH, which I have to determine. This is the volume of NaOH used. So by using this formula, we can find the molarity or of the NaOH or HCl. or I may say for NaOH or HCl, M1V1 is equal to M2V2. Molarity of HCl, volume of HCl, molarity of NaOH, and volume of NaOH. From this, we can find the concentration of the sodium hydroxide if it is unknown to me. Okay? We can find this value if it is unknown to me. Got it? Any doubt? Very important topic, titration curve. You know how do we made the titration curve? Any doubt you can ask me? Tell me. You
No,
got
sir.
it, Rio? Or any doubt is there? Tell me.
No, sir, no doubt.
Okay, now this is a reverse curve. If I take what I do, if I take in the beaker NaOH,
Sir, I have examined 11:20.
just I'm closing it in 1 minute only. Okay?
Yes, sir.
If I have NaH 25 centimeter cube, which is 0.1 mole decimeter cube, and if I add in the from the burette, if I add from the burette, this is my burette, HCl, then the curve will be like this. See, because for NaOH, you know, the starting pH will be around 13. This is the reverse of the what we have done. And again, when you have added 25 milliliter, you can see there is a slow increase, and immediately here you can see that pH is shifting from 11 point, this 12 point something to, you can see this point. So again, in this case, the equivalence point will be 7, pH will be 7. So we can do the reverse titration also. The graph pH curve will look like this. Okay, then thank you very much. We will meet you in our next class. Best wishes for your paper, and just revise and go for it. And then I will meet you in the next class. Okay, bye bye. Thank you very much for answering the questions. We will see you in the next class.
Okay, sir, thank you.
Okay.
Clear, Babu? Good, no? That's good, no?
Yeah, yeah.